Hello students, welcome to today's class. So the topic for today is relation. That's our next chapter, and pretty simple topic, relation and function as such. And the first subtopic is known as Cartesian product. So let's start the class. Okay. Cartesian product. First of all, if there are two sets A and B, so Cartesian product will be represented by A cross B. Okay, this is not exactly a multiplication of two sets. We'll talk about this with the help of an example. Okay, it's being represented by A cross B. So for understanding this, let's take one example. Let's take A set as 1, 2, and let's take B set as A, B. Okay, let's take C also. Okay, now if I have to do A cross B, first of all, Cartesian product of it, what I have to do is I have to write elements of A and elements of B in ordered pair. Okay, I'm using the word here, ordered pair. Okay, means I have to first take one element of A and combine it with one element of B. So that will create one ordered pair. Suppose I take 1 from A and the alphabet A from set B. If I combine them and put it in a bracket separated by comma, this is one element of A cross B. I have to do it for all the possible combinations. That means 1 will be related with A. Similarly, 1 can be related with B also. 1 can be related with C also. Okay. Similarly, we have to do for 2 also. 2 comma A, 2 comma B, 2 comma C. Okay. Now this 1 comma A, 1 comma B, this is the element of A cross B, which is called ordered pair. You can see why it's called a pair. Two things are there, and why it's called ordered, because it's in a definite order. First 1 is there, then A is there, because we are doing A cross B. So in ordered pair, the first element will always belong to set A. This element will always belong to set A, and this second element will always belong to set B. Okay, so order does matter in this. It's I cannot write A comma 1. I have to write 1 comma A in this. Okay. Similarly, we can do B cross A also. Then we have to write elements of B first and A later. Sorry. Okay. Now, I told you about ordered pair. Okay. Now, one thing that you should know about ordered pair, if two ordered pairs are equal, then corresponding elements will sorry will also be equal. What does that mean? That means suppose I write one ordered pair x comma y, and I say this is equal to A comma B, then x must be equal to A, y must also be equal to B. Okay. Now, if we understand this, we can easily do the first question. He's saying that these are two ordered pairs. No? They'll not say ordered pair, they'll just given that these two things, these two ordered pairs are equal. Clearly from this, you can judge that the first element of ordered pair here x by 3 plus 1 must be equal to 5 by 3, and this y minus 2 by 3 must be equal to 1 by 3. We can easily get the value. X by 3 plus 1 is equal to 5 by 3. So x by 3 is equal to 5 by 3 minus 1. If we further solve this, we get x by 3 is equal to 2 by 3. That gives x is equal to 2. Similarly, you can solve for the other one. Y minus 2 by 3 should be equal to 1 by 3. Y is equal to 2 by 3 plus 1 by 3. Y is equal to 3 by 3. That's y is equal to 1. Very straightforward. Okay. Now, he's saying next question, if we look about that, if set A has 3 elements and set B is this, find the number of elements in A cross B. For that, let's go back to the example that we just discussed. Number of elements of set A, how many elements were there? 1 and 2, so 2 elements. Number of elements of set B, that's A, B, C, so 3 elements. If we talk about number of elements of A cross B, I told you that 1 comma A itself is one element. So 1, 2, 3, 4, 5, 6. You can easily judge what's the relation here. That number of elements of A cross B is equal to number of elements of A multiplied by number of elements of B. Okay. So that's your formula, that how many elements are there in A cross B? We just multiply elements of how many elements are there in set A, how many elements are there in set B, and just multiply them. Okay. Based on that, I think we can pretty easily answer this second question. So for second question, I'm writing the answer here only. A has 3 elements, B has again 3, 4, 5, again 3 elements. So number of elements in A cross B will be 3 multiplied by 3, that's 9. Okay. Okay. Let's create some space here. Two we have already done. So I hope these first 2 examples that I have discussed, ordered pair, there is very straightforward. Achha, the purpose of a ordered pair is to we can use it to represent point in 2D plane also. Okay. And the second one is pretty simple, that elements of A cross B is elements of A multiplied by elements of B, number of elements. Now next question, it's given G set is given, H set is given. So G is 7, 8, H is 5, 4, 2. Okay. It's not necessary that elements of each set has to be different. They can be same also. Means H can also have 7 as an element. Okay. So it doesn't make much of a difference. So we have to find G cross H. Means first we have to write element of G and take it correspondingly with element of H. So G has 7. I'll combine it with first element of H, 7, 5. Then 7, 4, then 7, 2. Same thing you have to do for 8 also. 8, 5. Okay. 8, 2. Sorry, 8, 4 and 8, 2. I told you the important thing is that you write the element of G set first, because we are doing G cross H. And if we are doing H cross G, then we have to write elements of H first. That means use element of H first, 5. So 5, 7, 5, 8, then use 4, 4, 7, 4 comma 8, then use 2, 2 comma 7, 2 comma 8. That's just ordered pair. Okay, so that's your H cross G. Okay, so pretty straightforward questions so far. It's an easy topic. The first topic of relation is very easy. Okay. Next example. Let's create some space for this one. Okay, now what the question is asking is, this time is asking reverse. A cross B is already given to you. This is your A cross B. He's saying find set A and set B. Okay, so the thing to remember is that the first elements has to come from A. So in set A, definitely small a is there. Again, small a, we already covered, we don't have to write each element. We have to write each element in a set once. We cannot write it twice. And the first element here is B. Then again B, so we don't have to write it again. So set A consists of A comma B. Similarly, if we have to find set B, we have to look for the second element. The second element has X and Y. Again X, so we don't have to write again. Again Y, we don't have to write Y. So it's that simple. You can easily find set A and set B directly from this ordered pair. Just remember, first element comes from set A, second one comes from set B. Okay. All right. Next example. Let's slightly move this. He's saying A is 1 comma 2, B is 3 comma 4. He's saying write A cross B. So I'm not writing this. You can easily write this. Okay. Then he's saying how many subsets of A cross B will we have? Okay. How many subsets will have A cross B? You can actually write A cross B. But as such, you know, in order to find the number of subsets, you all you need is how many elements are there. Okay. So just tell me how many elements will be there in A cross B without actually writing the subset. How many elements? 2. How many elements? 2. A cross B, how many elements? It will have 2 into 2, that's 4. Now, if A cross B has 4 elements, how many subsets are there? So what was the formula for number of subset? That was from, we have discussed already sets. So assuming you know, I gave you the formula for number of subsets. So number of subsets is equal to 2 raised to power n. That means 2 raised to power 4. That's 16. That's your answer. How many subsets A cross B will have? 16. Okay. List them. So again, I'm not doing this listing them. You have already done how I already told you that how to write subsets. So 16 subsets, just for practice. If you want, you can attempt this. I don't think in the objective exam they'll ask you to write the subsets, but you should be able to identify the subsets. So you can practice this as a homework. Try to do this and this part on your own. Very straightforward, very simple. The key aspect is this. Okay. Then let's move to the next example. He's saying A and B are 2 sets such that number of elements of A is 3, number of elements of B is 2. And these are the elements of A cross B. So he is not directly giving you the elements. Let's number them something now. Let's say 1, we have already solved, 2, 3. That was solution 2. Now I'm doing solution 3. Okay. So A has 3 elements, B has 2 elements. He is saying A cross B. He's not given you A cross B directly, but he's saying few elements of A cross B are x comma 1, y comma 2 and z comma 1. Okay, again you have to use the same idea. The first element comes from A, x, y and z. They all comes from A. I think 3 elements we have to find, so we can easily identify now that A set has x comma y comma z as the elements, and B, the second element 1, 2, here second will be 2, 1, 2. Again we don't have to consider 1 again, because in set everything is written only once. So that's it. A has 3 elements, B has 2 elements. So he has not given you all these 6 possible elements for A cross B. He has given you few of them, and you can easily identify based on that. Okay. All right. Fourth one. Is saying that the Cartesian product of A cross A has 9 elements. This time he is not writing A cross B. He is saying you have done the Cartesian product of A with itself. Okay. So he is saying among which few elements were found to be minus 1 comma 0 and 0 comma 1. He is saying find set A and then find A cross A. So fine. Let's find A set first of all. Minus 1 comma 0. 0 comma 1. These are few elements of A cross A, not all. But if they are few elements, still the condition is same, that the first element has to come from A, and this time interestingly the second element also has to come through A itself. That means I can say A has minus 1 as an element and 0 as an element. Right now there are 2 elements. Let's see from the next one. Again, from this if I conclude that first element comes from A and second one also comes from this A. So 0 we have already written, so I don't have to write again. So what is left? 1. So minus 1, 0, 1. So A has 3 elements, and this satisfies this condition also. If A has 3 elements, then only A cross A will have 9 elements. 3 into 3, 9. Now this is your original set A. Now you can write A cross A. Cross another A. Let's erase this. A cross A. So in order to write cross, it's better to write both the sets, so you know which elements you have covered or not. Take the first element and combine it with the second set, which is A itself, with this, like 1, 0 and minus 1, 0 and 1. So minus 1 comma minus 1, minus 1 comma 0 and minus 1 comma 1. Okay. Same thing you do for your this 0 also. So for 0, 0 comma minus 1, 0 comma 0, 0 comma 1. I'm not putting too many arrows, otherwise it will get confusing. You can attempt on your own this thing. And lastly you do for 1, so 1 comma minus 1, 1 comma 0 and 1 comma 1. Okay. This one. Combine it with minus 1, then 0, then 1. So that's your A cross A. We can even do A cross A also. I'm not doing for this, but that's called ordered triplet. Triplet means of course triplet means now you will have 3 combinations effectively. Okay. I'll give you one example of that, so I'm not confused about it. Let's say A is one more example. No? First I'll put the heading ordered triplet, then I'll give you the example. Ordered triplets. These were ordered pair. Now we'll talk about ordered triplets. Let A is 1 comma 2. So ordered triplet first of all is being represented by A cross, let's say B cross C. 3 sets has to be there, and I ask you to calculate, let's say A cross A cross A is equal to. So first of all calculate A cross A. So 1 comma 1, 1 comma 2, then 2 comma 1, 2 comma 2. Okay, that's A cross A, and then again you have to do cross with 1 comma 2. Okay, I've done only this part first. That's your A cross A. Now combine this with 1, and then again combine it with 2. So if we combine this 1 comma 1 with another one, it will become a triplet known as 1 comma 1 comma 1. It's looking like a coordinate in 3D. This one again becomes 1 comma 1 comma 2. That's I've done for first element only. Now you do it for second one. Second one was 1 comma 2. Combine it with 1, and 1 comma 2 combine it with 2. Okay. Similarly for 2 comma 1, 2 comma 1 comma 1, 2 comma 1 comma 2. Lastly, I'll write here 2 comma 2 comma 1, 2 comma 2 comma 2. Okay. These are your ordered triplets. Okay. Now again the purpose is to represent, it can be used to represent a point in 3D, x, y, z. Okay. All right. So far all these concepts were revolving around this idea that what is a Cartesian product? We have to write ordered product, and in writing the ordered product, the first element comes from set A, the second element comes from set B. That's it, and we have to write all the possible combination of it. And one property, that number of elements of A cross B is equal to number of elements of set A into number of elements of set B. Okay. All right. Now let's talk about relation. See, directly or indirectly we have done this relation slightly in ordered pair. Remember, like for this 1 comma 2 and A cross B, I've written this combination A cross B. I've written all the possible combination, right? What if I write only few of them, 1 comma A, 1 comma B, 1 comma C, only that, or take any 3 or 4, that's up to me or you. Then that defines a relation, means very few elements of A will be specifically related with B. They may or may not be also related sometimes. Okay, that defines your relationship. Sorry, that's around your relation basically. Relationship between X and Y or A and B. So I'm not giving you any proper definition. What is a relationship? What is a relation? Okay, the relationship between X and Y will be depicted by some sort of mathematical equation that we have to understand. Okay, and you have to again use the notation that we used in sets to understand that how a relation is being defined here. So he's saying, let's say set A is 1, 2, 3, 4, 5, 6, all the elements, and there is a relation from A to A. A to A means we have to take elements of X and Y both from A. Okay, that X and Y both will be taken from A. That's the meaning of relation from A to A. Now how do we read this? R is a relation that is defined by X comma Y. So we have to write our answer or our relation in terms of an ordered pair. Okay, and double dot means such that, this we have already discussed, that double dot means such that Y is equal to X plus 1. Okay, so what I'll do is I'll show you first of all with the help of a arrow diagram. 1 second. Arrow diagram. Okay, now A, this is also A, because the relation was from A to A, na? So that's why I'm drawing a set. Now I'll represent the elements in a diagram way. Okay, with the help of arrow diagrams. I'll write the elements 1, 2, 3, 4, 5, 6. That's your set A. 1, 2, 3, 4, 5, 6. Okay. and usually the first one, okay, is called y, x, and the second one will be called y. Okay, both are set A. Now the relation is y is equal to x plus 1. So let's suppose x is 1, then y will be x plus 1, that is 1 plus 1, that's 2. So basically if x is 1, then y is 2. So 1 comma 2, I'll say, is a relation element for a particular relation. So 1 is somehow related with 2 as per this relation. So I'll show with a diagram like this, that 1 is being related. This is called arrow diagram. Similarly, I have to judge for all the possible values of x. So let's keep on judging. Now this time I will not write it, I'll just orally do this. So again, for 2, if x is 2, y will be 2 plus 1, that's 3. Okay. Similarly, if x is 3, y will be 4. If x is 4, y will be 5. If x is 5, y will be 6. And if x is 6, y is 7, but clearly 7 is not present. So how can I relate here? I cannot connect it with anything. So there is no relation present for 6th element as such. So these are the only possible relations possible. Now if I write it in ordered pair, it's called roster form. Okay. Remember what was roster form? Roster form was write all the possible elements. Now relation is being depicted in terms of ordered pair. So 1 comma 2, that's your relation R. We'll represent this also in form of set 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5, and 5 comma 6. That's it. So this is our relation R. Okay. So all we have to do is understand this condition, and remember that this ordered matter, if they have written y and x, so we'll write y on this set and x on this set. Okay. That means this order will be different. Instead of 1 comma 2, we'll take 2 comma 1. So first we have to write the elements of x that are being used for the relation, and then elements of y, the values which are being solved. That's your arrow diagram. This is the roster form. Okay. So we can represent in the form of a roster form. We can represent this in form of arrow diagram. And by default, you will be thinking that what about set builder form? The question itself is given in set builder form. Okay. So there are 3 ways to define a relation. Either they can give you in roster form, or they can give you in set builder form like this, or they can give you arrow diagram. You should be able to comprehend the relation in any way. Okay, so I've done the first part. I've depicted this relation in using arrow diagram. Now comes few words, technical words. Now those are domain, codomain, and range. Before explaining that, I'll first explain few names for these. Okay, these are called elements. These are called images. Okay, so if I say that 1 is the element, what is the image of 1? I'll say image of 1 is 2. Or if I say image is 2, what is the element for it? 1. Sometimes the elements are also called pre-image. Okay, so don't get confused with the words. You should know the names, that what is called what. Elements, image, or this is elements are also called pre-image. So if I say what is the image of element 1, you'll say 2. What is the pre-image of 2? You'll say 1. What is the element of 2? 1. Okay. How about 6? What is the image of 6? No image of 6, because there is no relation that is being satisfied. As such, for 6, 7 should be the answer, but the problem is that it was defined from set A to A, but inside A, 7 is not present. That's why I now cannot connect this with 7. Okay. Now let's define domain. domain are all possible values of x for which y is defined. Simply put, I have defined it in terms of x and y, so you can easily understand this. It's saying all possible values of x for which y is defined. Y is defined means there should be a y that is existing. So for this question, for this relation, if I say what's the domain, you'll say 1 is in the domain, 2 is in the domain because there is an image for it, 3 is there, 4 is there, 5 is there, but 6 is not in the domain. Means for 6 there is no image, means no value of y, that's why it is not in the domain. So if I have to answer the first part, I'll say the domain is only 1, 2, 3, 4, 5. So for this question, the domain is 1, 2, 3, 4 and 5, not 6. Why? Because for 6 y does not exist or y image is not there. Okay. Then comes word codomain. Now codomain is a very simple word as such. All you have to do is know the meaning. Codomain is all the possible values of y. That's it. Means doesn't matter whether it is connected with some element or not. Doesn't matter. You look at this one. One is not connected with any element in x, but still it will be part of codomain. Codomain is all possible values of y. These are not the way usually codomain and domain are defined, but I am defining this in simple words so you can actually solve questions easily. Codomain, all possible values of y. Range. Now we'll talk about range. So what about range? How we can define range? See, range are only values of y for which x exists. Means there should be a pre-image or element for that image. Okay. All possible values of y for which x exists. Okay. There should be x. That's it. Okay. So for this part, codomain, the answer will be 1, 2, 3, 4, 5, 6. But for range, 1 will not be included because there is no element for 1. There is no connection with x of this one. Okay. So for range will be 2, 3, 4, 5, 6. It's as simple as that. Okay. All right. So I'll repeat this one more time because this is the main concept of this chapter: domain, codomain, and range. Domain is all possible values of x for which y exists. Okay, so all these values, there is a y, but for 6 there is no y. So that's mean that will not be included in domain. Okay. If I talk about codomain, that is all values of y. Doesn't matter whether it is connected with x or not. It's as simple. Range only those specific value for which image exists. Oh, sorry, pre-image exists or element exists. So 1 will not be included. Okay. All right. So that was about domain, codomain, and range. Okay. Let's see one more example. So this time it's a diagram is already given to you which define a relation. Okay, arrows are being represented. He's saying write relation in set builder form, in roster form, and find its domain and range. I'll do the domain and range first of all. So domain was all possible values of x for which y exists. For this there is a y, although there are two y, or okay set this is x, this is y. So for 9 there are two y's possible, it's okay, but there are y possible, na? So that will be in domain. 4 again image exists, so yes, that will also be included in domain. 25 again will be included in domain. So for domain I'll say domain is 9, 4 and 25. What about range? Range are all possible values of y but for which element must exist. See, for 5 element exists, it is connected, yes. 3 element is connected, 2 something is connected. For 1 there is no connection of 1 with any value of x, so no. -2 yes, -3 yes, -5 yes. So for range that will be 5, 3, 2, comma, -2, -3, -5. Okay. Order does not matter in set. I think we have already discussed, so I can write this in any order, doesn't matter. Okay. That was domain and codomain. Now let's talk about the roster form. Roster form is easiest one to write, so let's do roster form first. Roster form. So for roster form, all I have to do is write them in ordered pair. First the values of x and then values of y correspondingly. So 9 is being related with 3. So 9 comma 3, and 9 is also being related with -3. So 9 comma -3. Okay. Similarly, what else is there? 4 is being related with 2, 4 comma 2. 4 is being related with -2. Okay. Sorry. 4 comma 2, 4 comma 4 comma -2. Similarly, 25 is being related with 5 and -5. So 25 comma 5, 25 comma -5. So in that manner, writing the ordered pair is very means writing the roster form is very simple. Just look at the element and it is being connected, separated by a comma. Set builder form, you actually have to write a relation. Set builder form. So first of all, I'll say r is equal to, then I'll say x comma y, because there are two values of then such that. Now I have to define the relation. So you can clearly see that these numbers 9, 4 and 25, they are square of the numbers that are being written here. So x is square of y. I told you we can write in terms of language, or we can write x is equal to y square, your call. Okay, either write this x is square of y, or you can write mathematically also. But we have to put constraint on x and y also somehow. So I'll say, since all the values are not taken, I have to justify values of y. I think I'll just create for value of y, because that will restrict values of x, and y belongs to natural number. What else? Clearly you can see what is the value of y taken here, from -5 to 5. Even 4 is not there. Very specific values are there, no? So either you write for y, or we should write in terms of x only. Let's write in terms of x. How can we restrict x? X is only 4, 9, 25. There is no pattern. We have to put restriction 5, 3, 2, 1. Either we have to write that x, we can write like this: x belongs to set P. Automatically, just forget about writing in exact condition. We'll say x belongs to set P and y belongs to set Q. That's it. So for Q and P, we have to write them in the set separately, or we can look at from the figure itself, because this complete diagram represents set P, this complete diagram represents set Q. So we'll directly say X belongs to set P and Y belongs to set Q. Because in general we can write, but see again 4 is missing from the pattern, so we cannot justify it properly. So this, anyhow, main key relation is this one, X is square of Y. That's it. Okay. So I hope the idea of domain, range, pretty much that should be clear, because usually the question will be around that part. Okay. And my suggestion to solve any kind of question for domain and range, whether the question gives you a diagram or not, you create this diagram, arrow diagram, because that will simplify it much more easily. Although we can do without diagram also, but it makes it simple. Plus the next topic that we'll do, function. Again, for that also it's very important that this diagram is there, because from that we can easily judge whether some relation is a function or not. Okay. All right. Next thing we have to talk about is total number of relations. Okay. So see, there are two sets again. A, suppose set A has P elements, set B has Q elements. Okay. And clearly A cross B will have PQ elements. Now the total number of relations is 2 raised to power PQ. This you should directly know. Okay. Now based on that, there is one example. I think solution is already there. Anyway, so A has 2 elements, B has again 2 elements. He is saying find the number of relations from A to B. So again, number of relation is, first for that we need this is your P, this is Q. So number of relation is 2 raised to power PQ. So 2 raised to power 2 into 2. That's 2 raised to power 4. That's 16. Either you do this directly, or I told you that A cross B will have how many elements? You don't have to write this. Just write down A cross B will have 4 elements. 2 into 2, 4. And for that, just try to write down how many subsets are possible. The number of subsets are same as number of relation. Okay. So either you do this with formula or without the formula. Anyway, this can be done. Okay. So a very straightforward question will come for this part. All right, this is done. Next, let's do functions. Now function is slightly interesting, I'll say. Not difficult as such, easy, but you have to understand the definition very clearly, and arrow diagram is must, I'll say. I personally prefer arrow diagram to solve any question for relation. For function. First of all, let's see the definition itself. He's saying a relation f from set A to set B is said to be a function if every element of set A has one and only one image in set B. What does that mean? I'll show you with the help of a diagram. Suppose this is set A, this is set B. So every element of set A should have one image. Every element. How many elements are there? Doesn't matter. Each element should have one image. There cannot be multiple images. Means for a single element, there cannot be 2 images. The moment one element will have 2 images, it will not be a function. Okay. So if something is like this, so yes, it is a function. If something is like this, so one element has multiple images, this will not be a function. Even if a single element does that, rest all are okay, but only one element is there, that is creating multiple images. One element has multiple images, not a function. Okay. Let's understand with the help of this example, perfect example to understand. So there is a relation given 2, 1. 3 comma 1, 4 comma 2, and he is asking that judge whether this is a function or not. Again, I will draw this. Let's understand this more. First one, he's saying 2 comma 1, so 2 is being related with 1 arrow. 3 comma 1, 3 is also being related with 1. Okay, 4 comma 2, 4 is being related with 2, like this. Okay, 2 has only one image, yes. 3 has only one image, although that image is same, but still 3 has only one image, not 2 images, yes. 4 has only one image, yes. As long as each element has only one and only one image, it is a function. So first one is a function. Second one, 2, 3 and 4 is there. 2 comma 2, 2 comma 4, 3 comma 3, 4 comma 4. Okay, look at the first element itself. This 2 has this as well as this. So one element has two images. One element has two images. Therefore, not a function. Second one is not a function. I hope that clarifies. Okay. Third one. Oh, sorry. I have to write. We have to create arrow diagram. No? 1, 2, 1 comma 2, 2 comma 3, 3 comma 4. I think this is the same one, the first example that we took, na? 4 comma 5, 5 comma 6, and then 6 comma 7 is also there. I think 6 comma 7 was not there. 6 comma 7. All right. Again, go for that. One element has one image, yes. Two element has one image, yes. Third element has one image. Fourth one, fifth one, sixth one. Every element has only one image, so yes. Each element has one and only one image, therefore a function. So yes, it's a function. So very easy with the help of this arrow diagram, I'll say. You can do it without arrow diagram also. It's just that you need understanding that like for this 2 has 2 also as image and 2 has 4 also as image. If you can see this, you can do this without the arrow diagram also, but with diagram it's very easy, I'll say. So if you want to play safe, go with the diagram. Plus grade 12th relation function. Again, relation function is there in grade 12th also. There again you will need these arrow diagrams. Okay, 1, 1, on 2, those kinds of things. In order to judge that, again you need these diagrams. So I'll recommend the arrow diagrams effectively, because it's not like this particular question will be there. They can be question based on 1, 1 and on 2. Those again are easily dealt based on this arrow diagrams. Okay, fine. So that covers your functions. So function only has one definition, that every element should have only one and one image. Okay, done. Now last thing that we have to cover are, there are certain functions for which the graph should be understood. The shapes, basically. You should know some standard graphs or standard functions as such. I'll start with something very basic that you must have done earlier also. Like, it's very basic, that might have been taught to you in grade 10th, long time back. Something known as y is x square. It's called parabola. Okay. We have a specific chapter on this also, but right now this U-shaped curve is called parabola. So whether this is x square, 2x square, 5x square, something like any number, doesn't matter. As long as there is power of 2, it's U shape. Okay. Interesting thing is, what if you have y equal to minus x square? So minus x square will be a shape like this. Okay. Same shape but inverted. A negative U shape. Okay. Then y equal to x cube. Okay. There is no name specific to it. It's a cubic function. So usually this is the shape of the graph. For 0, the value is 0. For positive values, y is positive. Okay. For negative values, y is negative. Whereas in this case, y is equal to x square. For both positive and negative values, x square is always positive. So the graph will be either upward only or downward. Downward is because of this negative sign. This negative sign is making the graph downward. Okay. Then this is a graph of y is equal to 1 by x. Okay. So when x is almost 0, 1 upon 0 is, as such we say, it's not defined, but it's almost approaching 1 by 0 is almost approaching infinity. So that's why the graph starts from infinity. As the value of x increases, as denominator increases, the overall quantity will decrease. So the graph comes down, and it is keep coming down, but it is never going to touch x-axis. Remember that. It is never going to touch x-axis. It is going to come as close to x-axis as it's possible, but never going to touch it. That's in the first quadrant when we have taken x positive. If we take x value negative, same thing will happen in the third quadrant also. Okay. All right. Then for this is a very famous graph. This is very, very important. Mod x, modulus function. Very important. I mean, every time a maths question, if they want to make it slightly difficult, all they will do is introduce mod. Now the working idea for this, let's start from like very early stage. Mod of 3 is 3. Mod of minus 3 is also 3. Means what is the function of modulus function? That it has to make the number positive. If it is positive, it will do nothing. But if it is negative, it will convert it to positive. The proper definition is like this. This is just for your basic understanding. The proper function is written like this. Like it is equal to y is equal to x if x is greater than 0, and it is equal to minus x if x is less than 0. Means for negative, it will introduce another negative which will make effectively this as positive. Now if we plot the graph, it's a V-shaped curve. Like you can easily judge it for like, suppose y is 2. So for 2, mod of 2 is 2, mod of 4 is 4, mod of 6 is 6. Like this, you can plot the points. But if you take minus 2, now for minus 2 mod is also 2, minus 4 mod is also 4, minus 6 mod is also 6. So first of all, the function is symmetric about this y-axis. Okay. This y-axis is acting like a mirror. What is present on the right side, the same thing is present on the left side also. Okay. So if you want to draw any graph, all you need is some basic values, 1, 2, 3, 0, 1, 2, 3, minus 1, minus 2, minus 3, and roughly you can plot the graph of it also. But this is the proper definition you should know about the mod. Okay. All right. So it's a V-shaped curve, and the V shape is at origin 0, 0. Okay. Next comes signum function. Okay. You should know, because the question will not say anything. The question will say it's a signum function, and they can ask you question based on that. Signum function. It is given y as sgnx. It will be written like this. Now signum function, what does it do? It is 1 if x is greater than 0, and it is minus 1 if x is less than 0. What about 0? As such, it's 0. The value is 0 for x equal to 0. Means at x equal to 0, we'll say the value of signum x is 0. If x is greater than 0, means positive. For positive value, means 1, 2, 3, 4, 5. You can see the graph is on plus 1. The value is y is equal to plus 1. Whereas this for less than value, less than 0, means minus 1, minus 2, minus 3. The value of y is minus 1. Okay. That's your signum function. Then comes your greatest integer function. This I will explain again. Greatest integer function. It is being represented by curly bracket. It will be represented by curly bracket x. Oh, sorry, square bracket. Y is equal to square bracket x. So this symbol is fixed, that this symbol defines greatest integer function. Although you don't have to get confused that what if the bracket is used for something else. Whenever they want to introduce greatest integer function, they will mention that this represents greatest integer function. So it will be mentioned in the question anyways. But as such, this is pretty much standard, that y is, if y is written like this, y is equal to x square, this is square bracket, then that means greatest integer function. Now what does it do? It takes out the greatest integer part available. What I'm saying? Takes out greatest integer part available. Let's say I take 3.7. So in 3.7, the maximum integer I can take it out is 3. I have to take the integer part, which is available. More importantly, the word available is the key part here. Okay. It doesn't matter whether it is getting close to 4 or not. What is available? From integer part, 3 is available. 0.7 will not create an integer. Similarly, suppose 5.1. So, sorry, square bracket. Habit of writing the curly bracket. Square bracket, square bracket. So 5.1, it will be 5. Greatest integer point. What about 0.7? So 0.7, the greatest integer part available is 0. There is no integer variable right now. Okay, let's say 1.999. Still, the greatest integer available to us is only 1, because still it hasn't reached 2. It is getting close to 2, but it is not exactly 2 right now. So the integer part still available is this. What if I take only 2 and we don't take any decimal place? So if I am writing only 2, any integer is directly written. The greatest integer available itself is 2. That means for integer parts, the greatest integer has same value. For 2 it is 2, for 3 it's 3, for 5 it's 5. For decimals we have to take out the integer part that is available to us. 3.7 has only 3 available to us. So if you look at very carefully, basically it's an integer which is less than the given number. Not exactly equal to, it is less than the number. Though it is saying greatest, but you have to understand the greatest integer part that is available means whatever integer is just below that number. 3.7, so 3 is there. Now let's talk about negative numbers. Negative, let's take minus 1.2. Now you might think this may be equal to minus 1, but look at the number line. For this you have to understand the number line, how it works. Minus 1, minus 2. Minus 1.2 will be here. Now right now as such, if you look at for positive numbers, let's say 3.7 was there, na? 3 was there and 4 was there. See, if we were talking about the greatest integer of 3.7, what we did is we took the integer which was less than this 3.7. So same way for minus 1.2, we have to take the integer which is less than minus 1.2, not more than. We have to consider the less than integer. So that means we have to take this minus 2. It's not minus 1, remember. 3.7, greatest integer is 3. Why? Because we are taking only the integer part that is right now available to us, 3, not more than 3.7. We cannot go more than 3.7, we have to go less than 3.7. Same thing you follow on this, but for negative number it will always be 1 less. Minus 1.2, it will be minus 2. Similarly, if I take minus 0.7, so try to think what is less than minus 0.7. What is the integer? That's minus 1. I think that pretty much, I hope, explains it. I'll take few more example. Minus 3.5, let's say. So that is an integer which is less than this minus 3.5. That's minus 4, not minus 3. Usually students have trouble with the negative function, negative working of this greatest integer function. Now if you plot these for all the points, if you consider all the points, so see, from 0 to 1, 0.7, the greatest integer was 0, 0.9, 0, 0.99, 0. So between 0 and 1, the graph is 0. Then exactly at 1, what is the greatest integer of 1? 1. So the graph will start from 1 itself. At 1, the graph is starting from 1. 1.1, again it will be 1. 1.2, it will be 1. 1.3 up to 1.999, it will be 1 only. It's just that it is approaching, when the value of x is approaching 2, the value of x y as such is still 1. At exactly 2, the greatest integer again jumps to 2. Means up to 1.999, it's 1. At exactly 2, it suddenly becomes 2. Then again 2.1, 2, 2.2, 2, 2.9999, again 2. But at exactly 3, it will again jump to 3. So the jumping is there whenever there is a integer. Okay, a jump of 1 step is there whenever there is an integer, and same pattern is followed in the negative also. So if you look at this pattern, you can see it is looking like a staircase. A person is there and he has to walk on this staircase. So it is also known as staircase function. Okay. So another name of this function, staircase function. Okay. But is it looking like a staircase? All right. A few important points, that jump of 1 unit takes place at x is equal to z. Now z is what? Integer. Okay, this is what we have learnt in sets, that z will represent all the integers. What else is there? Jump is there, and that's it, I think. What else is key here? It is looking like a staircase. I've already given you that. The greatest integer is equal to x if x is z. Means the value of greatest integer function is same only if x is belonging to integer itself, never before that. Z. Okay. So these are the two key points that might help you when we'll discuss about continuity, differentiability. Somewhere that will help you again. But the working of this greatest integer function is the key part. You should be very through how this function works. Okay, they'll not ask you directly a question on this. They'll combine this with some other topic and mix it up. Okay, so you should be clear with the working how this function works. Okay, I think that was the last graph. Yeah, we're done. So we have covered all the basic graphs. Okay, mod x, the key important one is this greatest integer function, signum function, mod x. These are very key graphs. Okay, these are still basics, I'll say. Parabola, cubic function, 1 by x. But these modulus function, signum, you should be very clear about this, how they work. Okay, means they are considered to be standard. They'll not explain you how a signum function will work. They'll give you a function based directly on signum function, assuming that you know how signum function will work. And yeah, another way to describe signum function is mod x by x. Okay, it is mod x by x. All right, fine. That sums up your relation. One small part is still not done here as such. That is, what if a function is given to you, means y is equal to suppose x square staircase function or something like this, and they ask you for domain of these functions. What about that? Domain and range. So for that you have to learn how to solve inequalities. So once we'll do inequalities, I'll explain there only that how do you combine those inequalities with domain. Okay. So in linear inequalities we'll learn about domain and range again. Okay. So apart from that point, this chapter is complete now. That's it. Okay, so it's a pretty small chapter but very important from understanding point of view, not too much difficult as a concept. Okay, all right, fine, that's it, we're done. All right, see you in the next class. Good day everyone.